And we're on to the last video for 5.3, still working on trig functions. So, another calculator example here, example 9, says using inverse trig functions to find angles. So again, this is something from geometry, but it says use a calculator to find the angle theta in the interval that satisfies each condition. Okay? So basically what we're going to do, and this is, I mean, depending on who you ask is how you explain it, but when you have cosine of some angle q is equal to something, we need to get q alone, right? So like if I was doing x minus 2 equals 5, and I said, what are you going to do? You say, I have to get rid of the 2, and I say, how? And you do, well, add 2 to both sides, okay? And the reason that works is because those are inverse operations. Addition and subtraction kind of cancel each other out, right? And so what this is the inverse operation of cosine, which is called inverse cosine. So on both sides, we're going to take the inverse cosine, look at this, cosine negative 1, of both sides. And what happens is the cosine inverse and the cosine kind of cancel, if you will. And so we get q equals the inverse cosine of 0.9211854, like that. Okay? Now, that's not that helpful, except for that's the calculator button, right? The inverse cosine is. It's just the 3, they're usually right above sine, cosine, and tangent. See them right here, sine, cosine, tangent? Okay? But, that's all there is to it, really. It's an inverse operation, okay? This is really dangerous notation. I really don't like it. Some people will use arc cosine, like this, and I prefer that, but the book uses inverse like this, and so we're going to do it that way. Okay? So all you do is type in 0.92, what is it, 118541, and then push the inverse cosine button on my calculator. Yours might be different, and I get q is equal to 22.899, repeating. Okay? So I should put 0.9 there, but I'll just do this instead. Okay? So that's that. All there is to that one, nothing crazy. Same thing here. Cotangent of q is this. That means that 1 over the tangent of q is 1 over this. Right? Kind of you could do that if you wanted to. Right? And so, sorry, I want to think of it differently. I want to think of, if the cotangent of this, then the tangent of that is 1 over this. That's what I wanted to say. Okay? So you flip it, right? And so now you just take the arctangent, or the inverse tangent, tangent negative 1 of that thing, 66474, and that will be your answer. So for me, I have to type in that whole thing. 1 divided by 1.44, 66474, enter, and then I push inverse tangent, and I get 34.654. Okay? Again, make sure your calculator is in degrees. Okay, and that actually solves for the angle. So the other ones we were solving for sides and whatnot, this actually solves for that angle. Okay, it's super useful. Alright, and then to finish up the section, we have an example problem, like an application. So we are looking at grade resistance. So basically going up and downhill. You'll see signs for this for semis on the road, like this is going to be a really steep hill. You don't want to go, you're going too fast in case you have to stop, that kind of thing. Okay? So it says when an automobile travels uphill or downhill on a highway, it experiences a force due to gravity. The force in pounds is called the grade resistance and is modeled by the equation F equals W sine of theta, where theta is the grade, so how up or down, and W is the weight of the automobile. Okay, so if it's moving uphill, theta is positive. If it's downhill, then theta is negative. Looking at this figure, and sort of cites it for you. Okay, so here's what we're kind of doing here. So first off, calculate F to the nearest 10 pounds for a 5,500 pound car traveling at an uphill grade of 3.9. So how much, force, if you will, does it experience? So we have F equals 5,500, that's the weight, sine of 3.9. So I'm going to do it in my calculator, so I'm going to do sine of 3.9 first. So 3.9 sine times 5,500. So I get 300, it says round to the nearest 10 pounds. So I got 374. So my answer would be 370 pounds. Okay? That's how much force there is with that example. Hopefully that makes sense. Okay? Part B, calculate it to the nearest 10 pounds for a 2,800 pound car traveling downhill with a degree of negative 4.8. So we're going to do force equals 2,800 times the sine of negative 4.8. So again, 4.8 negative sine times 2800. So in theory, the first one was going uphill with a 3.9 grade. So this is a lighter car, considerably lighter, right? Going downhill at a slightly less grade. So there should be less force, you would think. I haven't calculated this yet. We'll find out. Okay? So I get negative 234.2, so the answer is negative 230, right? Pounds. I didn't know that wrong, did I? Okay, which is less than the last one, right? It's not as big as 370. So about reasonable, okay? And the last one, we have a 2,400 pound car traveling uphill, has a grade resistance of 288. What is the angle? Okay? So we're kind of, remember this is the formula, F equals W sine of theta. So this is the force, so we know it's 288 equals the weight, 2,400, sine of theta, our first equation where we solve for theta. Okay? So step one, let's divide. So divide both sides by 2,400. And they get 0.12 equals the sine of theta. Now from example 9 in this section, we know to get theta, we just take the inverse sine of both sides. So theta is inverse sine of 0.12. And I get what? 6.89. Okay? So the angle of these 6.89 degrees, which is not a very big angle, but that is that. Okay? Hopefully this made sense. That ends 5.3. Thanks for watching.